Hi my friends, today we study this dynamic simulation made by me in 2014. You see, the support of the pendulums is free, not fixed, and the movement is created by gravitation only. Everything is natural, as you can expect, but in slow motion, of course. Let's see how to do such a work. The assembly is made of 5 components, but 2 of them are identical: pendulum and plate. I made this drawing for you. You see here the parts: plate, stand, and flat pendulum. I place here dimensions because I want to respect the original configuration in order to obtain the same dynamics. Let's start to create the assembly respecting dimensions. New standard millimeters IAM and place. The first is the plate, grounded at origin. You see, its position is not suitable for us. It was created in 2014, and then Z was here, not like today here. We force the position by selecting this corner and applying set current view as home, fit to view. Now you know that when I apply home, I obtain this special position. Okay, let's place another plate somewhere here, the stand, and the 2 pendulums, 1, 2. We place this. This is not movable, yes, it's grounded. The other, all of them can be moved as we want. They are not constrained, yes. The first distance is this one, 140, between the two faces of the plate, or not. The first is this one, 56, yes. I apply constraint, mate, solution mate. I select this face and this face, and I place 56 as the distance, yes. Apply. Then 140, but let me move a little this. 140 is a constraint. I can place here 140 between this, in order this and this. Apply. What other constraint we have to apply? Only this, and this is 14 between this and this face. You see, 14. Good. 14 between this and this. You see, this is not what we want. We want in the other direction. I place minus here. Now we have a good position. I cannot move this, not because it is grounded, you see the mark, but because I placed here in a fixed position. Good. Now I apply constraint 0 between these two, apply, and you see here 1 millimeter with this placed to the right and 2.5 here. Okay, 1 millimeter between these two, but flush not made, not 0 but 1, and I suppose minus 1. Let's see, 1. Did I? We can see by, yes, it is 1 millimeter. But the other direction, my friends, double click and I apply minus. Now you see what happens. Yes, okay, 2.5 is here, constraint 2.5, flush this with this. Okay, now pendulums. You see there is a short shaft here and a hole here. I place in position by using insert. Insert this here, apply. Then I insert this here. Okay. Now there are some angles. 4 degrees for this first pendulum about the axis of the stand. I select constraint angle this solution between the flat pendulum number 1. I suppose this is number 1. We'll see. No, this is number 2. I click and you see here. Yes, when you click on the part in the graphic space, you see which one is that part. Number 2. Okay, I want to place an angle between this angle and from the stand, not this angle, this plane, and from the stand also XZ. Yes, XZ here, XZ there. Constraint angle first solution 4 degrees between this plane and this plane, but not to the right. I want to be to the left, minus. all of them are fixed now. Yes, nothing is moving, everything, but not this one. Yes, this is free, and it must be placed at an angle of 27.5 or 27 degrees 30 minutes. I use the same constraint with the same solution, but now I place this is to be moved. I write here 27.5, and this again I have to apply minus. Okay, now I collapse everything, and we have a placement like the original. Let's do this. Environments, dynamic simulation, and now we can try to apply dynamics. I select the play button, and in 1 second nothing happens. Good, this is our first approach. The next one is to apply gravity. Double click, and I select this edge for applying the direction of the gravity. This line is okay, but not the direction. I change the direction to be down because the gravity force is down. Okay, I click on this object in the browser, and I eliminate presentation of the gravity, direction of gravity. Then I try again to see what happens. What happens? Everything goes down. You see? Interesting is when you take a look from here and apply perspective, because now you have the idea about the deep, and you apply run. You see, in 1 second the distance between these two is very large. Look here, one is here and the other is here. We can measure it. M from Monaco, any point of here with any point of here, the distance is 4.5 meters in 1 second, my friends. Okay, but we don't want to see this. I place back the object, the assembly of stand plus 2 pendulums, and I have to apply some constraints or joints. This is the tool for joints. As far as I know, few of you, my friends, are accommodated with dynamic simulation, isn't it? For this reason, I try to present each action step by step. The plates are fixed, yes? So movement can occur only at these 3 components. Motion can only cause collisions in 3D space. If you take a look at the browser, this list is the browser. You see a slightly difference from the browser of the assembly. This is the browser of the assembly, yes? And this is the browser of dynamic simulation. It contains parts which are either grounded or mobile. And these are the most interesting because they are standard joints which are converted from the constraints in the assembly. Constraints are this, this, and this. These are suppressed and so on. So we have to create new joints between these components. One joint is the contact of this stand with this plate. Yes? Another one is the contact between each component of the assembly based on this stand and the other grounded or constrained parts. I said that motion can only cause collisions in 3D space. This is why we use the joint, not rolling, not sliding, not 2D contact, but 3D contact. Between which components? The first is the contact between the stand and the plate. We select, click on stand and click on plate. Take a look here. Apply. You see, we have, besides standard joints which were present here, now we have force joints. We impose this joint. Yes? We impose that this stand to be in contact with this plate when everything is moving. It means that collides are interesting, not stationary placement with the constraints of this stand on this plate. Good. Now Inventor waits for me to select another pair of two components which can collide. This one can collide with the plate during the moving of them. Apply. This other pendulum can collide with this plate. Apply. We have 3D contacts now between all the three parts here with this plate. Now we apply the same constraints or joints between that three with this another plate. I select the stand, I select this, apply. I select the first pendulum and this plate, and finally I select this object and this object. Okay, now we have 6 joints here and we are ready to run the simulation. Let's do this. You see what happens, but not 1 second. I go to construction mode, not playing mode or simulating. I go here and I change this 1 second with 3 seconds. And because I want to apply slow motion, I can add a 0 here, but not now. Once again, you see how it happens in 3 seconds. We can also place them, as you can see, and we repeat the movement. You see what is the distance now? M from Monaco between this and any of this. Now is 15 meters, my friends. Good. Let's try to apply slow motion. I don't like that I don't have a collision with this. We can change other constraints and we can make this, but you are able to try anything you want. I have no time to continue with many other words. Take a look here. This is in slow motion because there are not 100 per second but 1000 per second steps in moving. You see how natural is this action. It has a contact here. We have almost everything. I apply home to see how happens with our objects. And this is 3 seconds with 15 meters between these 2 points. We have to wait a while because Inventor collects all these steps and it offers us the possibility to repeat step by step every movement. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have 2 options. 1. To contemplate what I do and apply my actions by creating your own components of this assembly. And 2. Try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones includes the previous ones. This is all for today. Thanks for watching. Bye bye.